Hello and good morning to everyone. This is Debasis Mohanty welcoming you all to our first chapter, Real Numbers. So today, first we will do the discussion of our exercise 1.2. Actually, exercise 1.2, all the questions it is dealt with the fundamental theorem of arithmetics, and everyone you have already known that the fundamental theorem of arithmetics has said that every composite number can be expressed as the product of the prime factors in a unique way of representation apart from its prime factor order of the prime factors. So first question it is given, express each number as the product of its prime factors. First question it is given for 140, and you know express each number as the product of its prime factor, it is also same as we have to express 140 as the prime factorization. We have to express 140 as the method of a prime factorization. Actually, prime factorization and expressing the number as the product of a prime factors both are same. So to get the prime factorization of 140, I have to do the continuous division by using our prime factors. So first prime factor it is 2. So whenever we will do the division of 140, we will get 70. Once again dividing by 2, we will get 35. On dividing by 5, we will get 7. Where we are getting the prime factors, we just have to stop the division at there. So for which 140 can be expressed as 2 into 2 into 5 into 7. Also, if one can write just like this, it is also correct. Otherwise, if one wants to write it in the exponential form, it has 2 square into 5 into 7, it is also correct. In the same way, question number II it is given that you just have to express 3825 it as the product of the prime factors. So in the same way, you just have to follow, and finally you get it as the 3 into 3 into 5 into 5 into 17, which is also same as 3 square into 5 square into 17. And the next question number I left and question number I left. Now I will do the question number B, and the question number B it is 7429. So suppose anyone is getting confused that which number can divide 7429. Suppose you are testing from the 2, 3, 4, 5 and everywhere you are getting fail, then after you will get confused that whether I need to check the number divisibility by each and every number. So actually here it is one formula. By using that formula you can do the prime factorization easily. That you just have to check whose square is just greater than the 7429, and I found 87 square is just greater than 7429. Then after whose square is just greater than that number, always you have to write all the prime factors less than that number. 87 is that number, so I am collecting all the prime number less than 87, just like 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. All numbers, all the prime number less than 87 I just collected, and no need to check the divisibility by each and every number. Instead of checking the number divisibility by each and every number, I just only have to check by the prime factor whether the prime factor can divide that number or not. And on checking, 2 cannot divide, 3 cannot divide, 5 cannot divide, 7 cannot divide, 11 cannot divide, then after 13 cannot divide. On 17 I got it as the number it will be divisible by 17. So on dividing by 17, finally I got 437. Then after 437, I just have to check it with the next prime factor. 17 gone. Then after 19, I checked. Then after dividing by 19, I got it as the 23. So for which the prime factorization of 7429, it is 17 into 19 into 23. So question number 1 it is very easy I feel, and also you also understood it easily I feel. Then after question number 2 it is given, find the LCM and HCF of the following pair of integers and verify the LCM into HCF is it equal to same with the product of the two numbers or not. So it means in the question number 2, two things it is asked. First it is asked that you have to find the HCF and LCM of the two numbers by using our prime factorization method. Then after you just have to check the product of the HCF and LCM is it same with the product of the two numbers or not. 26 which is equal to 2 into 13, and 91 it is equal to 13 into 7. So HCF means which factor it is the common, that factor you have to multiply. So it is here, it is 13 only, it is the common prime factor which is common in both, for which HCF it is 13. Then after LCM, it is the product of the prime factor used, product of the highest number of prime factors used in both the prime factorization. So 2 is used once, but below 1 2 is not used any number of times. So for which highest number of times 2 is used once, then after 13 used once, then 7 used once. So for which their product it is 182. Now the product of the two number equal to 26 into 91, which is equal to 2366, and also HCF and LCM, their product it is also 2366. So for which we got confirmed that the LCM and HCF, its product it is also same as the product of two number. Just like we have done this question, also double I question can be done, and here it is the question number third I. And in the question number third I, here it is given there 336 and 54, and finally after doing the prime factorization, I got it as the 336, it as the 2222 into 3 into 7, and 54 it is equal to 2 into 3 into 3 into 3. Also, without making it in the exponential form, also one can find out the HCF and LCM. But here by converting it into the exponential form, also we can find the LCM and HCF easily. So the formula after converting the prime factorization in the exponential form, the formula to find out the HCF it is the product of the least power of the common prime factors in both the prime factorization. Common factor 2 to the power 4, here it is 2, but the least power it is 2, and there it is the power of 3 is common, 3 is there, and here it is 3 to the power 3, so the least power it is 3. So for which HCF it is HCF equal to 2 into 3 equal to 6, and the formula to find out the LCM is it is the it is the power of the highest power, it is the product of the highest power of the prime factors used in both the prime factorization. 2 is highestly used in both the factorization, it is 4 times, so 2 to the power 4, and 3 is used there once, and here it is thrice, so highest number of times it is thrice, so for which 3 to the power 3. 7 in the upper prime factorization it is once, and 7 is in the below factorization it is 0, so for which highest one it is 7. So so the product of the 2 to the power 4 into 3 to the power 3 into 7 is equal to 3024. So the product of the two numbers is equal to 18144, and HCF into LCM, their product it is 18144. So finally we got that the product of the two numbers it is also same as the product of the HCF and LCM. Next question number 3, it is also same as just like the question number 2, but the difference between them is question number 2 it was the LCM and HCF of 2 numbers, but here it is given that the LCM and HCF of 3 number. So one question is you have to find out the HCF and LCM of 12, 15 and 21. So 12 prime factorization is 2 square into 3, 15 equal to 3 into 5, and 21 it is equal to 3 into 7. So HCF it is the least power of the common prime factor. Common it is 3, it is common in each and every prime factorization, for which HCF it is 3, and LCM it is the product of the highest power of the prime factors in all the prime factorization. So highest one it is 2 used highestly twice, and 3 is used highestly once, 5 used once, and 7 used once. So for which LCM equal to 420 and HCF it is equal to 3. Then after question number 4, given that the HCF of 2 number it is 9 and the LCM of 2 number it is X. Everyone knows the formula LCM into HCF is equal to product of 2 numbers. LCM into HCF it is equal to product of 2 numbers. As everyone knows the HCF, so we just have to put the value in the equation. LCM into 9 equal to 306 into 657. LCM equal to the product of the 2 number divided by 9. Finally we got the answer. Then after question number 5 it is given that check whether 6 to the power n can be end with the digit 0 for any of the natural number n. Whatever the value of n you may put, but the n value must be natural number. Can it be possible that for any value of n, the 6 to the power n, it will ends at 0? Roughly I am checking 6 to the power 1 equal to 6, unit place is 6, 6 square equal to 36, unit place is 6, 6 cube equal to 216, unit place is 6, 6 to the power 4 equal to 1296, here it is also unit place is 6. This one it is the rough method, everywhere I got it as any power of a 6. You may choose always the unit place, it will be 6. But with the formula how we have to write. Everyone knows that whenever the unit place is 0, it may be 10, it may be 20, it may be 30. You may factorize the 10, 20, 30, otherwise 100, otherwise 200, otherwise 210. Which number having unit place it has the 0, whenever you will do the prime factorization, always you can find that 2, at least 2 and at least 1, 5 is there. At least 2 and at least 5 must be there, such that the number having the unit place 0. If a number having the unit place 0, then after 100% 2, at least 1 2 and 1 5 must be there. But whenever we are doing the prime factorization of a 6 to the power n, 6 can be prime factorized as 2 into 3 to the power n. A into b whole to the power m equal to a to the power m into b to the power m. So for which is equal to 2 to the power n into 3 to the power n. It means on prime factorizing 6 to the power n, only we are getting it as the 2 to the power n, many more 2 we are getting, 3 to the power n, it means many more 3 we are getting. So it means only we are getting 2 and 3, but we are not getting any 5. So for which we cannot say that the 6 to the power n will ends with 0 for any of the natural value of the n. Then question number 6 it is given, explain why this number 7 into 11 into 13 plus 13 is a composite number. You know that to be a composite number, it can be expressed as the product of the prime factors. Composite number can be expressed in the way of prime factorization, and whenever we are expressing prime factorization, it means the number must be a composite number according to our fundamental theorem of arithmetic. Fundamental theorem of arithmetic says that composite number can be expressed as the product of prime factorization. So conversely I am saying if anyone can be expressed it as the product of the prime factorization, it means number must be composite. So first I am attempting from the expression 7 into 13 into 7 into 11 into 13 plus 13 into 1. 13 means 13 into 1. So from both the term 13 can be taken it as the common. After taking 13 it as the common, within the bracket 7 into 11 plus 1. So which is equal to 13 within the bracket 77 plus 1, which is equal to 13 into 78. On prime factorizing 78 we will get it as the 13 into 6. Once again 6 can be prime factorized it as the 2 into 3. So for which finally we are getting that given expression can be expressed in the way of 13 into 13 into 2 into 3. So it means that expression can be expressed as the product of the prime factors. So for which as the expression can be expressed as the product of the prime factors 100%, that expression will give which number? 100%, that number will be the composite number. So how I made you understand the question number I, in the same way the double I question also can be done. Then after question number 7 it is given that someone is taking one character, it is Sonia. Sonia is taking 18 minutes to run around a field and Ravi is taking 12 minutes to complete one rotation around the circular field. Then it is given that if they will start their running from the same starting point, after how many minutes? Once again both of them will meet with each other. So here I am showing you the rough work. Sonia takes first round 18 minutes, second round 36, then after fourth round, third round 54 minutes, fourth round 72 minutes, and Ravi will take first round 12 minutes, then after 24 minutes, then after 36 minutes, then after 48, 60, 72, and finally we got at the time of 36 minutes and also at the time of 72 minutes, also after the time of 108 minutes also once again they will meet with one another. But here it is given that after how many minutes they will meet, it means minimum less number of times such that they will meet with each other. So for which here it is clearly seen that the first time after which once again they will meet with each other, it means 36. Actually it's another meaning it is also tell me the least minutes after which once again both of them will meet with one another. So after the least time means least minutes means LCM of 18 and 12 you have to find out. LCM of 18 and 12 just like fundamental theorem of arithmetic. Otherwise by using the prime factorization method you just have to find 18 equal to 3 square into 2, 12 equal to 2 square into 3, LCM equal to the product of the highest power of the prime factors of both the prime factorization, which is equal to 36. Hence after 36 minutes both of them will meet with each other. Okay, I hope the exercise 1.2 it was very easy and you understood all. Many thanks for watching the video. Okay, thank you, have a nice day.